G'day champions, got a VHT in today. It's a bit tricky, I should have taken the camera off the tripod, but there's the control panel. Single channel tutor. Show you the back panel. Classic 18. Product of USA, manufactured in China. So, this one has come in with crackle, no hiss or hum, and ring modulation sounds otherwise fine. So ring modulation to me means we've probably got a open or failed filter cap, because it'll be riding on top of the 50 Hz or the 100 Hz from the mains, the rectified mains. So I don't think I'll power this one on. I'll take it apart first. If it was something minor, we might power it on just to witness the issue. But I want to inspect it visually first before we go applying power. So I'll crack it open. So first thing I notice is the speaker connections are super loose. Like they're actually moving back and forward. The best thing to do is snip them off and hard solder them to the speaker terminals, but because there's no speaker jack, it just disappears into the chassis there. That means you'd have to desolder them every time, and possibly melt the insulation a little bit more each time. So retensioning these may be an option, but the cheapy Chinese ones tend to be made out of such a thin metal that you retension them, you put them on once, and they've already loosened off, and you take them off again and put them on. They just bend back like after using them once, and if not, they actually break when you try and retension them with the pliers. So I might crimp on some proper ones, some nicer quality, heavier gauge ones. It's a Celestian greenback G12M. So that's nice. It's got that going for it. Does the job. So we'll remove this reverb wiring. It's little saddles there. See, I hate these things. They're loose, but you can't get them off. Oh, that's the ones with a little catch. Got me again. So some of them have a little thing you got to press with your thumbnail. I'll just show you up close so you don't struggle with them like I do when I'm not paying attention. Just pull back the little sheath there. You see there's a little catch in the middle. Kind of hard to make out there. You can sort of see it there. So when you pull it out, that little catch releases like a little dimple there, which holds onto the little hole in the center of the eyelet, the center of the tag, and that releases it. So you can be struggling, feels like it's really tight, but you just got to push that little tab in. Now that was a sneaky little bugger. They were using the chassis for the 4 handle screws, so you undo the 1, 2, 3, 4 top chassis screws, you've got to undo the handle as well, as well as the back panel screws. And it's very tempting to put this thing down this way on the bench, but then what you do, you'd snap off the tips of the two EL84s there. So then you'd be up for owing the owner a new pair of valves. So it's not looking great construction wise. It looks like it's a bit of a just throw it together and we'll figure it out later sort of construction. It's pretty thin pressed steel. 2-piece chassis. And screws everywhere. So, let's start removing screws, I guess. Yay! Oh, that's some nice shock mounting there too, isn't it? You just put a bit of schmoo on the around the chassis and hope for the best. It's not doing anything. Still rattles. And it looks like we've got some kind of plate that we'll have to remove. No, that should come out by itself. Got a dumb retainer which has got Loctite or something on it. What a pain. Like these tried and true methods of assembling an amplifier. Why do you have to reinvent the wheel and make a super complex to fold chassis? Well, you could have made it out of one piece, a la Fender, but no, that'd be too easy, wouldn't it? Anyway, I'm not going to just complain in every video, I promise. Alright, so now we've got a standoff. Seems to be the only thing holding this cover in. And the standoff's spinning. And the screw on the other side is covered with a sheet of neoprene. So, feels like there's not a screw there either, so I think that's a rivet that's spinning. So I'm just going to go brute force, grab the old beer openers. There we go. So the first thing you might be wondering is, where are the transformers, bro? Well, they're tiny and they're inside. So there's your output and there's your power. That's nice, a natural opportunity for shielding, i.e. mounting them outside the box. They've foregone that for cheap manufacture. What valves have we got? Got a Sovtech 7025 12AX7 12AX7, another one of them, and two EL84s that look in reasonable condition for once. So maybe this thing doesn't cook valves. It's amazing. A manufacturer respecting EL84s? Never. So that's promising. Now they've got a sticky piece of double-sided neoprene tape holding the two chassis together. Just checking that we won't destroy anything if we just lever it up. No. I'll get my spatula out. And there we go. Easy as. So you got to wonder if this is worthwhile. Reverb plugs just fit through their little gland there. I think they probably fit by accident more than anything else. So there we have it. No signs of any real crustiness around their leads. Doesn't mean they're functioning. We've got some solder joints that look like they've gotten hot, but not on the valves. It almost looks like the valve sockets have been reflowed by someone at some point. The screw heads, some of the screw heads were a bit reamed over, but that doesn't really mean anything when you're talking a cheap Chinese amp. They often come like that from the factory, so no biggie there. Now we've got leaded solder there because it's nice and shiny, and evidence of like flux burnt flux around the solder joints, but the solder joints look okay. Oh, that's fun. All the components, yeah, well, obviously all the components are on the other side of the board. So it's, yeah, I don't know if I want to get involved in this one. So let's take stock and think about this. Are we going to be able to test it while it's out on the flat on the bench? Well, let's have a look. All the pots are mounted to the circuit board. This ribbon connectors going to the output, an effects loop and foot switch board. they have sufficient play in them. Transformers all connected via quick connects. Got switches going to the other side of the board, and you got valves hanging down from the other side of the board. I think we might be able to test it in this position. Just leave it all together and maybe glean enough to figure out what's going on, because we've got no component designators on this side. You can't even see which component's which. So it'll be a matter of trying to find a schematic, test as much as we can with it in this position, and then replace what we've established needs replacing, and then reinstall it and try and make that as quick as possible, because this thing could turn into a pretty big time suck for a not very expensive amp. So it's almost like this amp was planned to make servicing as impractical as possible. You've got the circuit board, which is flipped over. The components are on the underside, facing the chassis. No component designations or any markings on this side of the board at all. You've got the valves hanging down. To access the controls, you have to have it flipped up that way, which means that you can't really take any measurements to the board that you can't see any designations on anyway. I wonder, do they do it on purpose? Just like, fuck you, don't fix it, throw it in the bin, buy another one. But I can't get over this problem with that logic, whereas if you've bought an amp and it failed in an unreasonably short time, the manufacturer wants you to throw it out and buy another one, but they don't seem to have connected that you probably won't buy one of theirs. You'll buy someone else's. So I don't get that logic. I'm not a economics major, so maybe there's lots of people out there smarter than me that can explain how that makes sense. So anyway, first things first, looking for a T1A, so slow blow 1 amp fuse. And that's what we've got. And it looks intact, we'll check that in a sec. And mains fuse 500 milliamp. And that's a 1 amp. Oh sorry, that's a HT fuse. Yeah, 500 milliamps. And then put a 1 amp in there, so that's interesting. Why 4? You have one amps in 100 watt Marshall heads. So I wonder if someone was having issues and they replaced it. So, champions. Today is tomorrow. When it comes to low budget repairs like this, it's a matter of rolling with what you got. So, what do we have access to without doing a lot of labour? If we take this board out and everything, we're going to be like an hour in the hole at least. 2 hours when you're making videos, but you know. So what have we got access to in its current state that we can glean as much info from as possible? So we've got access to the output transformer primaries. We can measure the voltage drop across them and the resistance, and derive from that the bias point of these valves and the balance. So that's two things. We can also, just using the resistance, check that the output transformer is okay, just like continuity wise. We have access to the valve pins, so we can check voltages, we can check the heater voltages are getting where they should be, we can check the grid voltages, there's no caps leaking through and sending one of the preamp stages out of bias. We can check the plate voltages and make sure that the plate supply resistors are okay. We can glean a lot of info from that. We can scope it, find out at least which stage the signal is making it to, if there was a signal issue. I don't think there is in this case, but we'll fire it up in a minute and we'll check that. We've got access to all the filter caps, which is actually kind of nice. If one of them's failed, we can pull it out from this side without pulling the board, so that's actually an advantage. We can also check the voltages on each node because we have access to all the pins on the caps there, and they appear to be arranged in a reasonably logical fashion. We can check if there's one of the dropper resistors, which, just looking here, it's probably from there to there. You can sort of figure out the way they were thinking just looking at the traces. So we don't have a schematic for this, and even if there was one, we might not even need it. So sometimes amps like this, although they're cheap, if you think logically, they can actually be easy to repair than some amps, like you know, like a matchless or something that's all point to point. Things like this are probably easier to diagnose than a point to point hand wired amp, as desired as they are. So what else have we got to go off? We've got the power transformer secondaries, so we can check that all the AC voltages are coming out okay. And if we have a look underneath or just use a bit of logic, we can see that here's probably the rectifier. Looks like a bridge rectifier here. So we can check the DC output of that. We can also, having the bottom of the PCB exposed means that we can easily check all the solder joints. That's not something that you could easily do on some amps like the Hot Rod series, for example, where you've actually got to pull the board to check the solder joints. Here they're all in your face. So although it seems like a difficult amp to service, there are advantages, and you've got to take advantage of them and run what you brung. Alright, so first, as always, we'll just check the filter caps, got no voltage, 90 millivolts, 90 millivolts, all nodes are likely the same. Yep, and we'll check the resistance of the output transformer. You can probably hear a little tiny pop from the speaker. Yep, 111.1 ohms on one side, 89 ohms on the other, 88.7. That imbalance is no biggie, because remember, we're dealing with DC here. That's what the multimeter's measuring. So naturally the inner windings are going to have a lower resistance because there's less length of copper there than the outside windings. But to an AC signal, it's seeing the turns ratio, so they're probably the same impedance or very close, but the DC resistance of the inner winds is going to be lower than the outer, so no biggie there. It's the same on pretty much every transformer. Guys get in a panic about it and think they've got to replace the output transformer. Well, you know, you'd have to replace every output transformer known to man unless they were bifilar windings, which tend to be a bit on the high-end side, like the hi-fi stuff. That's where they basically run the wires like a Y, and then they both have the same distance. But for instrument amplifiers, close enough's good enough for rock and roll, isn't it? So what I like to do first is set the variac to the minimum possible voltage, which isn't 0 volts. It's more like, I don't know, 40 volts or something, 20 volts. Fire it up, got the standby and the power switch on, and then I just like to probe around and just check that the relevant voltages are where I expect them to be. So we've got like 6 volts on the plate of that preamp valve, 6 volts there, 6 volts there, 6 volts there, so it's getting plate, 6 volts there, 6 volts there, yep. So that's the plate connections on the EL84s. Obviously the center tap's going to have 6 volts as well. In that case, there's not going to be any noticeable ripple even if one of the caps is buggered, but every cap there has voltage on it. This is all reference to ground, obviously. Just check we're getting some kind of negative supply on the bias, minus 72 millivolts. So I'll just bring the voltage up. We're running signal into the speaker. I'll just keep an eye on the power meter and make sure there's no massive jumps in dissipation as the heaters start to allow the valves to conduct. At the moment everything's just sitting static. I'm sitting at 50 volts input, 75 volts, and we're only sitting at 10 watts, so that's promising. 20 watts at 150 volts, about 28 watts at 200 volts. We're starting to get signal. So we'll just have a listen to the quality of that signal. check the balance on either side. 312 volt, 312 volt, reasonably balanced. We're only sitting at about 200 volts input. We're drawing 50 watts, and we've already got the data sheet maximum for a EL84. So it's probably another amp that runs them way over spec. Okay. Ooh. I think we've got a bad valve. Crackling. That sounds to me like an EL84 on the way out. It's one of those situations where you touch anything and it makes noise. So the power's just jumped up a bit. So because the power's jumping up and that valve's hotter than the other one, I'd say we've got a bad EL84. We'll just confirm that. I mean, it's noisy, so chances are it's bad EL84, but we'll just check the bias isn't falling over on that one as well. Minus 3.6. Minus 6. Okay, so that's getting dragged down, but it's probably getting dragged down by the valve itself. So the easiest way to check this, just pop in a known good pair. And you might get away with just a, yeah, that one's way hotter than the other one. That one you can easily hold, no problem. This one you can't hold for more than 3 seconds, so that means it's over 70 degrees. So, bad EL84, I dare say. Let's chuck a new known good pair in there, and we'll see how she do. Now, a lot of this is probably because they do run them so over spec. Like, you often see amps where they're running EL84s to like 400 volts, man, and like a 7189 is okay, but they're pretty well obsolete now, and new old stock versions are getting extremely expensive. You throw NOS in front of everything, you can multiply its price by about 4 times these days. It's just a buzzword, but everyone goes for it, so everyone does it. I'd prefer new production valves from a trusted supplier myself, but what do I know? Oh, let's give them a chooch. Oh, I've got to stop saying that. I say it every video. I've been watching too much AVE. Alright, we'll bring her up. Just watch the current again. Some plate voltage coming up on each side. Just stop there for a minute. 98. 98's are pretty balanced. Let's check our bias voltage. Minus 3.7. Minus 3.7, so we're nice and equal now. We're drawing less current. So we'll go to 200 volts. We've got signal. We're drawing 27, 28. Oh, that's about the same as before. Then it's coming up 35 watts as they start to conduct. And microphonics are gone. Cool. So hopefully that's all that was wrong with it, because it's probably all the budget would allow on this one, considering they're pretty cheap amps. Just have a tap around, make sure there's no intermittency. Get rid of the meter, it's in the way. There's a couple of solder joints there I'll touch up anyway, but they don't appear to be intermittent. At first I thought that plate connection had an issue, but that was just the valve being super sensitive. Just turn that off, crank her right up, check for any massive noise. No microphonics on the preamps. All the spade connectors, quick connects, whatever you want to call them, they're all pretty tight inside the amp. So luckily it's not. Looks like they might have a different one for the speaker connection. or just maybe that one's been undone a few times. Yeah, it looks like that might have sorted it. So we'll give it 4 mains. We'll see. A bit of a squeak there. That was probably some solid state circuitry doing something weird. Just set everything to 12 o'clock. Plug it directly into the mains and we'll take some measurements. Alright, so we'll just check that everything's discharged. About 5 volts sitting on the plates and every node. We'll take the measurements of the output transformer primaries. So we had that before. Now it's gone up a little bit because it's warmed up a touch. So yeah, about 112 and about 89. 112.89. Remember that for me, would you? So I've set the variac to best case scenario about 240 volts. 242. We'll see how it behaves at the ideal voltage of 240. At the moment in standby we're drawing 35 watts. Make a note of that. Now get rid of the ground connection to the chassis. Check the voltage drop on each side of that transformer. Now we know the known resistance. So fire it up. That's dropped down to about 56 watts. So you can derive from that about what the output stage is taking and factor in, I don't know, a watt for the preamp valves per valve, like half a watt per triode or whatever. It's a ballpark. It's near enough to know something's seriously wrong. The more accurate way of doing it, don't try this at home. We've got 2 point, doesn't matter about the polarity which way you are, but I'll do it this way just to make more sense. 2.6 volts drop from red to brown. 2.2 volts drop red to blue. Next we determine our chassis to cathode, just to check that there's no weird hybrid biasing arrangement. And we can go cathode to plate, 348, 349. But because there's no difference between the chassis and the cathode, we can just measure chassis to plate, which is a bit more convenient. 349 volts, 340, say 9 volts. So because we've only got one valve on each side, we can just go 2.6 volts divided by 112 ohms equals 23 milliamps. Multiply that by the plate voltage, 349 volts. So 8.1 watts. What? 8.9. And on the other side we've got 2.2 volts divided by 89 ohms. So that gives us 24.6, say 25 milliamps. Multiply that by the plate voltage, plate to cathode voltage, 8.6 watts. Now the maximum dissipation on the data sheet for an EL84 is 12 watts, so you can go 8.6 divided by 12, so we're running at 70, say 72% on the right hand side, 68% on the other. So good enough for rock and roll. That's actually pretty good. They're not flogging them like rented mills like a lot of other amp manufacturers. Of course, being a combo, they cop it a bit more mechanically than some amp heads, so they won't last quite as long as a head format. But I'm feeling confident that that's probably all that's wrong with it. So let's plug in a bit of guitar and we'll have a listen, see if there's any weirdness. Alright, we've got everything at 12 o'clock again. The reverb's not plugged in, but I'll check that, as well as the speaker actually. We'll give it a sweep and just check that there's no weirdness in the speaker. There's a strange fuzz underlying the decay of the note. There's a lot of stuff that sympathetically vibrates in this shop though, so I might have a listen through the cab a bit closer and see what's going on there, but it sounds like everything's reasonably healthy. Just check a couple of voltages in the preamp too now, and then we'll put some signal through the scope and see what it's putting out. So just checking the voltages on the preamp valves, we can tell we've got a cathode follower there, and that one's the preamp valve. So I dare say this is probably a bit of a rip-off of the 18 watt Marshall circuits. It sounds similar, maybe a little bit more gain, a little bit more overdrive, and then some solid state reverb circuitry on top of that. So nothing new under the sun, eh? But without a schematic, that's my best guess. I've got a feeling that fuzziness is one of these preamp valves being a bit weird. These are Russian 12AX7s, and Russian 12AX7s generally don't like being in cathode follower stages that much. They tend to break down a little bit between the heater cathode connection because there's too much potential difference there, exceeding the specs of the valve. Whereas the JJs and the Chinese valves tend to put up with that a little bit more readily. So we'll maybe swap one out, see if it's within budget. It's a very, very slight fuzz. If he's running it with a fair bit of gain, he probably won't even notice it. So I'll just let him know. Maybe we'll just leave that in because it's reasonably easy to change without opening the thing up. And he can maybe do it at a later point if it gets worse, or if it starts bothering now that he knows that it's there. So anyway, I think that's all we can really allow for this one at the moment, champions. Luckily it was a pretty easy fix, just a new pair of output valves and an overall check and service. The valves, the pots are a little bit scratchy, so I'll take the knobs off and see if I can access through the shafts to work a little bit of lube in there, just to try and clear them up a bit, because they're circuit board mounted. They're plastic shafted, a little bit like the Blues Junior ones, but vertical mounted off the circuit board, so you can move the knobs back and forth like crazy because it doesn't have those little bushings that the Blues Juniors have to stop that from happening. But you know, it is what it is. It's a cheap amp and it's a reasonably cheap fix, so happy days. See you on the next one, champions. Take it easy. You know, stay hydrated. Clean your sheets. I don't know. Have a good one.